Welcome to all of you. In this session, we are going to learn one more program, that is the exchange of the data between internal memory and the external memory. So the statement: write an ALP to exchange the source block starting with the address 10H internal memory containing n, that is 6 bytes of data, with the destination block starting at location 2000H, that is the external memory. The registers we are going to make use in the program, that is R0, it holds the internal memory address, DPTR holds the external memory address, and the R2 holds the count value, and obviously there will be accumulator registers. Now let us start with the program. So R0 is used to indicate the source memory location, that is internal. DPTR is used to indicate the external memory location, that's the destination memory location, and R2 is used to hold the count value. So A and B are used to store the data of source and destination temporarily. Now let us get into the program. So move R0 comma hash 10H. So that is the source memory location as per the question given, that will be stored to the R0. Move DPTR comma hash 2000H. The memory location, that's the external memory location value, will be stored to the DPTR. Since it is external memory location, that must be pointed by DPTR only. So we are using the DPTR for that. Then move R2 comma hash 6H. The block size or the count value of, or the number of values to be exchanged between source and destination is stored in R2. Now move X A comma at DPTR. From the external memory location pointed by the DPTR, the value will be moved to the accumulator. Then move B comma at R0. The value pointed by the R0, that is the internal memory location, will be stored to the B. A and B are going to act as a temporary memory locations. So XCH A comma B. So we can also directly make the movement of the data, but here we are just exchanging. We are using XCH instruction in order to exchange the data between A and B. So now the value which was previously present in A, that has moved to B, which was previously present in B, it has been moved to A. Now move X at DPTR comma A. So the value which was there and the internal memory is now moved to the external memory. Move at R0 comma B. The value which was there in the external memory, now it is being moved to the internal memory. Now increment R0, increment DPTR. Now decrement the count value R0. If it is not equal to 0, then move back and keep repeating this loop again and again till R2 becomes equal to 0. Now let us see the simulation of the same program. Now the data that we are going to make use of will be of this pattern. So this is the internal memory location. There we are going to store the data 10H, 20H, 30H, 40H, 50H and 60H sequentially, and this is the external memory location starting from 2000H. So there we are going to store the data from 0AH up to 0FH sequentially. Now let us observe what happens in each iteration as per the data that we have considered. Now starting from here, move R0 comma hash 10H. 10H is the memory location. Now in this instruction, this is an immediate data that we are loading to the R0, because R0 will be the memory pointer to the source location. Then move DPTR comma hash 2000H. So DPTR is loaded with the 2000H, which will be the address of the external memory. Then move R2 comma hash 06H. That's the count value, the number of data to be exchanged. Then starting with the loop part, so move X A comma at DPTR. So since we are making use of the external memory location, we are using the instruction move X. The content pointed by the DPTR will be loaded to the accumulator, that is A is equal to 0AH will be loaded. Similarly, the source location we need to store the data, move B comma at R0. So B will be loaded with the value 10H, and that 10H is stored in the location pointed by the register R0. So we are making use of one more instruction, exchange. So between the content between A and B. So exchange A comma B, that is A which was previously 0AH stored has got updated by the value 10, that is exchange between the A and B registers are happening. So now which was B which was having the value 10, now it has got loaded with A. That means whatever the previous contents of A and B, they have got exchanged, and those values are now available in the updated registers values A and B. Now move the content of A to the DPTR, that is pointed by DPTR, that is at location 2000 10H will be stored, and now similarly here at location 10H the value 0A will be stored. Now increment the R0 memory pointer, that will be 11H, increment the DPTR, that is the external memory pointer, that is 2001H, decrement the counter, that is R2, which was previously 6, now it has become 5, so it is still not equal to 0, therefore the execution moves to the loop once again. Similarly, these are the other iterations. As you can make the observation, total 6 iterations we require, because the count value here we have loaded it as 6, and in each iteration you can make an observation of the changes. So in the last iteration, when R2 becomes equal to 0, the execution will exit from the loop and the execution will end. After the completion of the execution, here is the comparison. Before execution, this was the data that we loaded or we considered, and after execution, the exchange of the data has happened between the source and the destination, that is between the internal memory location and the external memory location. Now let us simulate the program. So first build the program, no errors. Start with the simulation. Now try to adjust the memory over here. Let us load the respective memory location. So I will take memory 1 as the internal memory. So I colon 10H, and memory 2 as the external memory. So it is X colon 2000H. We need to load the data to the memory locations. To the internal memory, I will take it first. So I will load the data. So 10H, 20H, 30H, 40H, 50H, 60. So total 6 values, 6 data we need to load. So total 6 I have taken. So it has been loaded. For destination also we need to load, because it is the exchange of the data. So I will take 0AH, 0BH, 0CH, 0DH, 0EH, and 0FH. So total 6 data over here, right? So now this is internal memory and this one is external memory. Now let us start the execution. Just make then observation in the respective registers for the change. Move R0 comma 10H. So R0 is updated. So 10H, then DPTR is updated with the memory location. Then the count value loaded to the R2. Then from the DPTR we are moving the data to the accumulator. So that is value 0A is available in the external memory, that is moved to accumulator. Then from internal memory we are moving it to B, that is the value 10H. Now we are exchanging the values. So that is the A and B content have got exchanged, and then move the accumulator data to the destination. Now as you can observe in the memory 2, the value has been updated. Now in the memory 1 also you can observe, so the value has got updated. Now increment the DPTR, that is external, increment R0, that is internal memory, increment DPTR, that is external memory, verify for the R2, it is still not equal to 0, decrement it and move back to the loop until R2 becomes equal to 0. So keep repeating this process until all data has got transferred. So you can keep observing the changes in the value in the register screen. So now only one value is remaining, all the values has got changed. So now R2 becomes 0 and the execution has got ended. So this is a sample program. So programming can be done in some other ways. So if for example in the line 12, so xch a comma b has been written. So you can observe, so instead of that we can also make use of this instruction, which will avoid one instruction in this overall program. So still there may be other ways of doing the program. This is just a sample procedure just to make sure that the question is satisfying, the program is satisfying the question what has been asked. Thanks for watching.